6.2, Part 2, two sample confidence intervals. Okay, so this scenario, there is a rivalry between the AP Calculus students and the AP Statistics students at a large high school. They often argue about which group has the higher average SAT score. To settle the matter, they take random samples of 10 students from each course. The sample mean from the AP Calculus group has a mean of 1320 with a standard deviation of 56, while the AP Statistics group has a mean of 1352 with a standard deviation of 108. Both population distributions of scores can assumed to be approximately normal. Construct and interpret a 99% confidence interval for the true difference in mean SAT scores between AP Calc students and the AP Stat students. That will help us with our parameter. Okay, so they kept talking about means and standard deviation, so hopefully that was a good clue in for you that this is a means problem. So define our parameter. I am going to, they don't give us a subtraction order, but when they're talking about them, the calculus students came first, so I'm going to say the mean for C for calculus minus the mean for S for stats. So to define that, that will become part of my definition here for your true difference. So go ahead and write your definition of your parameter and put your subtraction order at the end of it. So our parameter is the true difference in mean SAT scores between AP Calc students and AP Stat students, and then I wrote Calc minus Stats, so that automatically defines our C and our S up here with a confidence level of 99%. So as I mentioned before, I like to put my statistics in here too, so I have them easily available to me. So the mean for the Calc students was an SAT score of 1320 with a standard deviation for the Calc students of 56. Then we had a mean SAT score for the Stat students of 1352. And they have a standard deviation for the Stat students of 108. Okay, this is a means problem, so that means we have to have a degree of freedom. When you have two different groups, you're going to use a smaller sample size for your degree of freedom. These sample sizes are both the same, so my degree of freedom, which was n minus 1, would be 10 minus 1, which is 9. Now, so there's our state. We have our parameter, we have our confidence level. The rest doesn't have to be in there. It's just good to kind of have all of your information. If nothing else, you could have written it out in the margins so you had it available for you. Okay, so now our plan. Remember, in our plan, we need to name our procedure. This is two different samples. So we have a 2 sample. It's a means, which makes it a T interval. And what are we trying to estimate? We're trying to estimate mu calc minus mu stats. All right, so for random, it says there's random samples. Now what you need to be sure you mention here is there could be people who are in both AP Calc and AP Stats. We have them this year even. So we want to say that these are independent random sample, meaning somebody's not being used for both of them. So we're going to say independent random samples. Okay, so we have independent random samples of 10 students from each class. Okay, so that's our random. It is a random sample, so you definitely have to check your 10%. So we have 2 samples, so you have to check this twice. So we have a sample size 10, which would be less than 1/10 of, we'll say this one's the all AP Calc students. But it's not all AP Calc students in the whole world, because we're talking specifically at this school. So at this school, and then we'll do the same thing for AP Stats. 10 is less than or equal to 1/10 of all AP Stats students at this school. They said it was a large high school because you would have to have 100 AP Stat students and 100 AP Calc students with no crossover. So in a large high school, that could be possible. Okay, so random 10%, and the last one is your normal. Now this was nice. Remember we have 3 ways to check normal for means, and one is, the first one you should always check is about the population. And our scenario did say that both population distributions are assumed to be normal, so we're going to say that too. Both population distributions are assumed to be normal. All right. So we got our state, we got our plan. Next is the do. So I want to show you the specific formula so we kind of understand where all of our numbers are coming from. So to get our point estimate, you have the statistic for the calculus minus the statistic for the statistics. And then plus or minus, we're going to have a T-star because it is a means problem. Okay. And then our standard deviation for this is on the formula sheet. All you would do is look under the two sample for means to get this. We have to use the standard deviation from the sample, but remember we don't use the standard deviation, we use the variance. So you got to square that divided by this sample size. Okay, and then we have for our sample from statistics, we need the standard deviation for the statistics, but remember we got to turn it into a variance, so you square it divided by the sample size of the statistics. So when we plug everything in, we're going to get the calc minus the statistics plus or minus. Now we had our degree of freedom of 9, so I went to table A for a 99% confidence interval and went up to 9 and got a T-star of 3.250 times the standard error. Standard deviation for calc was 56, so square it, divided by their sample size of 10, plus the standard deviation for statistics was 108, square it, and they also had 10 for their sample size. So calculating it out by hand by putting this into the calculator, I got negative 157.03 to 93.03. So I want to caution you here. If we use our calculator to determine this interval, let me show you what I'm talking about to be careful with. So go into Stat Tests. This is a 2-sample T interval, okay, because it's means. So when I go in there, the mean for calculus was 1320 with a standard deviation of 56, and there were 10 of them. The mean for statistics was 1352 with a standard deviation of 108 with a sample size of 2. My confidence level is 99%, and always answer no to the pooled question here. And then we're going to calculate, and I want to show you what happens. It's got to think. Now, notice that these numbers are different. Here's why. So choose one or the other. Don't put both of them down. So in the calculator, it gave us negative 147.2 to 83.2. But what do you notice right below there? It says DF, that's your degree of freedom, of 13.51. It used a different degree of freedom with us for this, so we need to be very, very careful that for the two samples, you either rely all the way on your calculator, because then this number is going to be different, okay, or you go straight all the way in hand. So you're going to have some differences here. Okay, so just be very, very careful. If you're going to use the specific degree of freedom from the calculator, you got to use the calculator for the whole thing. But I recommend you write it out by hand and just put it in your calculator to get this number. This one's a little bit easier. The calculator is a little bit newer to us, so I wouldn't worry as much about trying to make the two sample t-interval work. All right, so for our conclusion, go ahead and pause the video and write your conclusion and see how you do. So we are 99% confident the interval -157.03 to 93.03, or if you did the whole thing straight in the calculator, you would use the other interval. Captures the true difference in mean SAT score between AP Calc and AP Stats students. Calc minus Stats. Now this question does not have a follow-up, but if they had asked, does this provide convincing evidence that there is a difference in the mean SAT scores between AP Calc and AP Stats students, we would have to say no here, because 0 is a plausible value. It's in our confidence interval. And remember the previous video where we said you also have to talk about the alpha. So if we have a 99% confidence interval, the 0 is a plausible value, so it's plausible there is no difference between here, which means an alpha of 0.01 would not find evidence for a difference in the means. All right, so hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.